Okay, students, first task for you to do is to tell me your name. Of course, this is a recording of this lesson, so when we do it in class, you'll do that on the Pear Deck. I'm going to ask you about how you feel about your knowledge of power so far, so you can drag the icon to let me know where that is. It's hard to do that when you're watching a video, but on the Pear Deck, you'll do that. So our first thing is talking about what is a power. Now, this is an overview lesson. This should be review of what we've learned, so we're just kind of making sure we've got these concepts. So power is a way to represent repeated multiplication. So when we look at it, we've got this figure 5, big number 5 to a small number 2. 5 is the base, and the exponent is 2. The whole thing, 5 to the 2, is the power. And this represents a repeated multiplication of 5 times 5. So 5 multiplied times each other 2 times. So whatever we have for the base will be multiplied times itself the number of times of the exponent. So your task here is to, on the Pear Deck, you would circle the bases in red and circle the exponents in blue. Now obviously you can't do that on the video, so I'm just going to show you the solution. So here we have all of our bases are circled in red. We have the 6, the 7, the 6, not including that negative sign because there's no bracket around that base. The 3 over 2 is the entire base, and the negative 7. Those are our bases. Our exponents are the 0, 5, 0, negative 2, and 3. So they're the small number up in the corner. So we should be able to identify that. Here you're asked to express exponents as repeated multiplication. So on the Pear Deck, you would be asked to express these as repeated multiplication. So, of course, you can't do that on the video, so let's see what it looks like. So for the first one, we've got negative 2 to the 7, so I'm repeating the multiplication of 2 times itself 7 times. So negative 2 times negative 2 times negative 2 until I've got it 7 times. Obviously, because there's brackets around the negative 2, the entire thing needs to be multiplied. And I put brackets around it, that negative 2 for clarity. For 3 to the 4, 3 is my base. The number of times I'm repeating the multiplication is 4 times. So it's 3 times 3 times 3 times 3. 3 times 3 times 3 times 3. Yeah, 4 times. Okay. All right. So now we're moving into exponent laws. So the first exponent law we looked at was product of powers. When you multiply powers with the same base, we keep the base and add the exponents. So here in our example, both of these exponents, a to the m and a to the n, have a base of a. So we're going to keep that a as we multiply them. So we keep the a as the base, and we add those two exponents, m plus n. That's the expression of that exponent law, the product of powers. Okay, now I've got an example here, negative 2 to the 4 times negative 2 to the 7. They both have the base of negative 2. So I keep that negative 2 as my base. I'm going to add those exponents, 4 plus 7. So it'll be negative 2 to the 11. If I want, I can now evaluate. Negative 2 to the 11 is negative 2,048. So this is an opportunity for you to try some. You may want to pause the video, try these two questions, writing them as a single power and applying your product of powers. And then when you're ready, press play and I'll move to the next slide. Here we go. So 5 to the 5 times 5 to the 4. I keep the 5 as a base and I add the exponents 5 plus 4 and I get 9. Second example, negative 4 to the 1 times negative 4 to the 3. I keep the negative 4 as my base, and I add the 1 plus the 3. Now remember, we don't always write that 1, because sometimes we're lazy. Any any number that doesn't have a power or an exponent, we will say is to the exponent 1. Our next law that we looked at was the quotient of powers. So this is when I've got an error in my slideshow. This should say when you divide powers with the same base. Keep the base and subtract the exponents. Oops, I better fix that before I teach that lesson. Okay, so we have here a to the m divided by a to the n. A is the base for both of them. I'm dividing, so I subtract the exponents. So we get negative 9 to the 10 divided by negative 9 to the 6. I'll get negative 9 to the 10 minus 6 equals 4. Yeah, 10 minus 6 is 4. Okay. See, that error is still in here. So I've got to make sure I correct that before I teach this lesson, don't I? Yeah. Now I'm distracted. It's all good. So we've got two examples here, negative 2 to the 5 divided by negative 2 to the 3, and 6 to the 5 divided by 6 to the 1. You can pause the video, try those, and then we'll go to the next slide and we will correct them. Okay. So let's see what happens. So, yep. So negative 2 to the 5 divided by negative 2 to the 3. So I keep the negative 2 as my base. And 5 minus 3 is equal to 2. Bingo, right? So, and then for 6 to the 5 divided by 6 to the 1, I keep the 6 as my base, and 5 minus 1 equals 4. So, it's kind of neat because they're kind of like little partner laws, right? The quotient of powers and the the product of powers. Okay, with multiplying you add, with dividing you subtract. Now, here's a little review of what is anything to the exponent 0 equal to. So let's remember, take a moment, think about it. You might be shouting it at the video. Let's see what it is. It's equal to 1. Doesn't matter what it is. Notice with those negative bases, they have to be in brackets. If they're not in brackets, then the 0 is just on the number and not the negative sign. But generally, anything to the power of 0 equals 1. All right, power of a power. When we bring a power to a power, we keep the base and we multiply the exponents. So here, I have a to the m brought to the power of n. So I will keep that base a and I multiply m times n. So my example is 3 to the 2 to the power of 4. So I keep the base 3, I multiply 2 times 4, and I get 3 to the 8. Now I could evaluate that, but I didn't have to for this one. So here you're going to do this for these 3 examples. I have minus, and then in brackets 2 to the 4 to the 5th, and then I have 6 to the 2 to the 7th, and then I have in brackets negative 3 to the 4 to the 2. So let's see. Alrighty. So here, the negative sign stays outside because it's not included in that power. So it's negative 2 to the 20. Okay, so I know my answer is going to be negative. Here, no negative signs. I don't have to worry about it. I go 2 times 7, and I get 14. Oh, when I got the 20 on the first one, it's because it's 4 times 5 equals 20. And then here, I can deal with those two exponents. I keep my negative 3, my base, in brackets. 4 times 2 is equal to 8. So it's negative 3 to the 8th. All right. Oh, I have a strange blank slide right in the middle. I wonder if that's there. Yes, it sure is. Okay. So the next one, and we just learned this yesterday, so this might be kind of new, and it's just about distributing. Sometimes, particularly as we move into polynomials, and we're going to start using with variables, and we often can't evaluate inside the bracket first, right? Remember, we're order of operations. So there's a simple rule called the power of a product. So if I have a product brought to a power, I can distribute the exponent to all the terms in the brackets. And basically what I'm doing is I'm applying the power of a power rule. I'm multiplying that exponent by their little exponents. Most of them will have an exponent 1. Occasionally, we don't. And I have done an example like that on the next page. So here I have 3 times 4 to the 5. I distribute the 5 to both, and I get 3 to the 5 times 4 to the 5. So here, you're going to do these ones. Now I've done one with numbers. You're going to write each of these as a product of powers. And then I have one that with variables. Okay? So pause it, try them yourself, and then check out the next slide. Okay, so here I distribute the 3 to the 6 and to the 4. So I get 6 to the 3 times 4 to the 3. Now here, I wrote it out a little more. I'm basically taking 4 times 2, because it's like a power of a power. So I have to multiply those exponents, and I get a to the 8. And then I'm going 4 times 3. So I get b to the 12, because 4 times 3 is equal to 12. So I'm distributing that 4 into both those exponents. It's like a power of a power, so I multiply them. Last law, power of a quotient. All right. When we bring a quotient, a division, to a power, we distribute the exponent to all the terms in the brackets. So just like power of a power, or power of a product, power of a quotient, we're distributing. We just want to make sure everything in the brackets gets its little piece of that outer exponent. So if I have a over m divided, it's like a to the m divided by b to the m. I've distributed that m to both of the terms in that quotient. For my example, 78 over 13 to the third, I get 73 to the third over 13 to the third. So that 3 just gets attached to both of those terms in the quotient. All right, so now we have examples. I've done one with numbers and one with variables, just to show you how it works. So we're going to write these as quotient of powers. So you might want to pause it, figure out the answers for yourself, and then I'll go to the next slide. Here we go. So 1 to the 5 over 2 to the 5. The 5 gets attached to both. Now some of you might be saying, well, 1 to the 5 is just equal to 1. It is, and you could just write it as 1, but this is asked as a quotient of powers. If you wrote it as just a 1, I would still give you a mark for that because it is correct. And then we have x to the 2 over y to the 2. The 2 is distributed to both those terms in that quotient. Doesn't matter that they're variables, the same rules apply. All right, so now if this was a lesson, which it would be in class, I would ask you to circle how you're feeling about exponents. That felt like a lot, but it should all be review. So if there's any areas where you're having issues, like if you're looking going, I really didn't get that power of a product, then you might, in the lesson, you might talk about that. Here is draw or type 2 things in today's lesson, so you might want to think about what did you learn that you didn't know before, or what was reinforced for you that you really understand. It's a good opportunity to kind of do a little check-in. All right, now this page sums them all up. So once we know what an exponent is, we have our product of powers. So that's when we're multiplying with the same base, and that's when we add the exponents. This is a nice slide. It's got lots of info on it. We have the quotient of powers. That's when we are dividing powers with the same base, and we subtract those exponents. Remember, for our purposes, m has to be bigger than n. We're not generally dealing with negative exponents. I'm going to talk to you about them, but we don't have to assess on them. Then we have power of a power, a to the m, brought to the power of n. If we have that situation, we're going to multiply those exponents. And then we have power of a product. So this is where we're distributing. So if I have ab to the power of m, it's like a to the m times b to the m, and then power of a quotient. A over b to the n is like a to the n over b to the n. That sums all of them up. Hopefully, we're going to do more practice with them, because I know that you're working on your science because you've got that unit test coming up. And I want to make sure that we really get them solid. And I have the time to do it, so I'd rather take my time to do it. Okay, but that's our lesson.